Hi everyone, this is Mrs. Terigno, and this is the Chapter 6 Quest Review. You just received this in class today. Your quest is tomorrow. Remember, it's about the size of a quiz, but it covers quite a bit of material, and it will count as a test grade in the test category of your grade. So make sure you are well prepared. The first one just says to simplify, which means that you just want to multiply it out and combine anything that you can. And when I say multiply it out, I'm referring to FOIL, using the FOIL method to multiply. And remember, FOIL is really just the distributive property done twice in a row. So here I would take x times x, or I'm sorry, x times negative 3x. That gives me negative 3x squared. Just remember, anytime you're doing an x times an x, you end up with an x squared. X times negative 2 is negative 2x. 4 times negative 3x is negative 12x. And 4 times negative 2 is negative 8. So from there, really all I have to do are combine my two middle terms here, because those are like terms. And my final answer would be negative 3x squared minus 14x minus 8. And that's simplified. Now number 2 says to expand and then simplify. Well, expand just means to consider the fact that this is being squared. And to square it, that means I'm going to write it out twice. So I'm going to write out 5m minus 6 times 5m minus 6. And then I'll repeat the exact same process I did up with number 1. 5m times 5m, that's 25m squared, negative 30m. Negative 6 times 5 is also negative 30m. And negative 6 times negative 6 is positive 36. So when I condense that and put my like terms together, I end up with 25m squared minus 60m plus 36. Okay, jumping down to number 5. An important distinction is in number 5 is that they're asking you to solve. Remember, solve means find out what g actually equals. You don't want to actually work this out. You don't want to do FOIL here where you multiply g plus 1 times g plus 1, which I know is your first instinct because of what we just did. But if I'm solving unsquare, okay, so think for a minute about what unsquare means mathematically. First, I'm going to move this 10 over to the other side because I can't do anything until I do that. So I end up with g plus 1 squared equals negative 100. And now at this point in the game, instead of squaring this, I want to do something that's going to get rid of that square. And so I would take a square root. Okay, take the square root of both sides. Now normally I would proceed from here. I would take the square root and the square and I would cancel them out and I would be left with just g plus 1 equals, and then I would set it equal to whatever the square root of this side was. But hopefully you're seeing a problem over here, that a square root of a negative number is not a real answer. That's a no solution problem. So as soon as you see that there is a square root of a negative number, we know right away that there's not a solution. Okay, there's no number that I could put in for g that would make this equation true. Okay, let's look at number 6. Number 6, if you're confused about where to start, pretend that square wasn't there. Pretend it just said 5x plus 3 equals 8, and think about what you would do first. I would subtract the 3. That leaves me with 5x squared equals 5. Now some of you are going to be tempted to take a square root right now. But remember, we don't want to take a square root until we've gotten rid of everything except the square. So let's divide by 5 to get rid of that 5 in front. That's going to leave me with x squared equals 1. Now I can take a square root, and I end up with x equals, plus or minus 1. Because remember, the square root of 1 could be positive 1 or negative 1. And if you wrote that out as two separate answers, that would be fine too. Okay, number 7, it's our favorite picture frame problem. A painting that's 5 by 7 is to be surrounded by a mat W inches wide. So here's my painting, my 5 by 7. Here's the mat. And I know that's W all the way around. And I want an expression for the total area of the painting and the mat. So really what I need to know is this whole distance down here and this whole distance up the side, because this is a rectangle. So to be able to find area, I need to do length times width. Okay? So down here, I know the length of this side is 7 from here to here, plus I have a W here and a W here. So my total length, and I'm going to write this over here, would be 7 plus 2W, because I have a W on either side. Up the side, it's similar. I know this is 5 from here to here, just based on the inside here. And then this is W and this is W, so the length of this side is going to be 5 plus 2W. And then to get area, I'm going to take these two expressions and multiply them together, again using FOIL. So I would do, I'm going to put this over here, 5 plus 2W times 7 plus 2W. When I FOIL that out, I'm going to end up with 35 plus, outside would be 10W, inside would be 14W, and last would be 2W times 2W, which is 4W squared. And then if I wrote that out as a simplified expression, it would be 35 plus 24W, and I add those W's together, plus 4W squared. And that's your simplified expression. Now some of you may have written that with the 4W in front. That's perfectly fine too. Technically that's considered to be more like standard form, but I would accept your answer like this too. Okay, number 8, give a simplified expression for the shaded area. Notice the shaded area is the area in between the two rectangles. So, what I really need to know is the area of the outside and subtract the area of the inside. Or I could think of it as the area of the big rectangle and subtracting the area of the small rectangle. And we're talking area here. So big area minus small area. Okay, so to get the area of the big outside rectangle, I'm going to multiply these two things together. I'm going to multiply 7x plus 5 times 4x minus 3 and then I want to subtract, because I said that's what I'm ultimately wanting to do, the area of this one, which is 2x times x plus 6. Okay. So here I'm going to go ahead and do FOIL again. 7x times 4x gives me 28x squared. 7x times negative 3 is negative 21x. 5 times 4x is 20x. 5 times negative 3 is negative 15. Now, here's just a hint for you. This negative sign tends to mess people up a little bit. What I would do is I would attach that negative sign directly to the negative 2x, or directly to the 2x, making it negative 2x. And then when you distribute it, you can just treat it like a negative 2, and that'll allow you to just add together all of your like terms instead of having to worry about going back later and subtracting. So negative 2x times x gives me negative 2x squared, and negative 2x times 6 gives me negative 12x. Okay. Now I'm just combining like terms. So 28x squared minus 2x squared leaves me with 26x squared. Then I have a negative 21x, a positive 20x, and a negative 12x, which, let's see, that's negative 1 minus 12 is negative 13x. and then I think just a negative 15 floating around here too. So final answer would be 26x squared minus 13x minus 15. Okay, let's move on to the back. Okay, 9, 10, 11, you know what, I'm gonna swap it out here. I have a clean copy that's not all bled through. Okay, the parabola below is a translation of the image of y equals x squared. Now it's not shown on this graph, but y equals x squared would look like this. It would be centered right at the middle. Okay, so we took this parabola and we slid it over to the right until it landed right there. And what I want to know is how far did I move it? And if you count, we moved it 3 in this direction. We moved it 3 to the right. Okay, so my translation, I'm going to use a t, and then I'm going to say I moved 3 to the right and 0 up and down. So just t, 3, 0. Now remember when you do that, that these numbers here really represent your vertex, which are h and k. So if I want to write an equation in vertex form, and remember vertex form looks like this, y minus k equals a times x minus h squared. All I have to do is plug in my h and my k, and then we'll talk about the a value in just a minute as well. So y minus k, that would really be y minus 0. And if it's minus 0, you don't have to include it, okay, because anything minus 0 is just itself. So y equals, now my a value, again I get off easy here. I would have to look back at my original equation and look for the number that's in front of x squared. Well, there's nothing there. Hopefully you catch that that means it's really a 1, but if there's nothing written there, I don't have to write anything here. If you wanted to write something, you would have to write a 1. And then it would be x minus 3 squared. Okay. Now it says rewrite the equation in standard form. This was the new stuff we just did today. And remember, there's no magic method for getting the equation in standard form. You just have to simplify it as best you can. This one's actually not too bad to simplify because you don't have any numbers hanging out here in front of the parentheses. All I have to do is expand and simplify this, the x minus 3 squared. So I would have, I'm going to jot this over here, y equals x minus 3 times x minus 3. Okay. Let's FOIL that together. So y, equals x squared minus 3x minus 3x, and then negative 3 times negative 3 is positive 9. I don't have to move anything away from the y. I don't have to distribute anything. I can just combine my like terms, and my final answer is y equals x squared minus 6x plus 9. And that's considered to be standard form. Okay, let's take a look at number 10. Number 10 is a Newton's formula problem. Okay, and the formula for Newton's formula, which you will get on your quiz, is negative 1/2 gt squared plus v sub 0 t plus h sub 0. Okay, now you do have to know which numbers or what letters stand for what. So my equation, I'm going to start writing, well, I guess I'll write it over here. H equals negative 1/2. Now my g value, g is not given to you in the problem. G, you always have the choice between 32 and 9.8. And 32 is if you're working in feet, 9.8 is if you're working in meters. Since this problem is in meters, I'm going to do 9.8 t squared plus, that v sub 0 stands for initial velocity, which is given to me right here, 23 meters per second, so that would be 23t, plus the initial height, which is how high it is when it's starting. If he's hitting a baseball from a height of 1.5 meters, that would be right here. Okay. Now the only thing I would probably do to that to simplify it a little bit is write h equals negative 4.9 t squared, and all I did to get that was do negative 1/2 times 9.8 plus 23t plus 1.5. And that's your equation. Okay. Excuse me, I'm sorry, I'm so tired today. Okay, what is the height of the ball after 2 seconds? Well, mathematically, you could take that 2 and plug it in here for t. Okay? Or you could do this in a calculator. Now, just to review the steps on your calculator, I'll go ahead and do it that way. Oops. So let me wipe out what I already have in here. Now, in my calculator, I'm going to type in this equation, except I'm going to put x in instead of t. So y equals negative 4.9. I should be able to see the buttons too. Negative 4.9 x squared plus 23x plus 1.5. And hit graph. Now this right now is on a standard window. It's on the window that I very first start my graphing calculator with. And that's not a very good picture of what this ball is actually doing. So I need to adjust my window. Remember, when you're trying to pick these numbers, it is okay that you just guess a little bit, but let's guess rationally. Let's guess logically. X represents time. The smallest time you're ever going to look for is 0. So your x minimum is 0. That means starting right this minute, okay, if your time is 0. And x max, if you think about how long it would probably take a baseball to hit the ground after it had been hit, I would say my x max is maybe about 5 seconds. Okay, probably not a whole lot longer than that, but we can always adjust later if we're wrong. For my y values, y represents height. My minimum height that I always want to look at is 0, because that's right on the ground. Okay, I don't want to go underground at all. And then I have to think about how high this might go. And this is where it might be tough, especially if we're thinking in meters. People might be a little bit harder to think in meters because we're so used to thinking in feet. So about how high a baseball would go, I'm going to take a guess and say, 20. Whoops, 20. And hit graph. Okay, my guess was wrong, and I'm glad it was wrong, okay? In fact, I sort of guessed wrong on purpose, because I wanted you to see what happens when you get a picture like this. You don't have to freak out. You don't have to raise your hand and say, oh, look, there's something wrong with my calculator. There's not. You just can't see the top of your graph, so we need to make our graph go up higher. If you look back at those window settings, the way I make my graph go higher is by increasing that y max. I'm going to make it maybe 50. And then look at my graph. Okay, and that's a perfectly good picture. As long as you can see the entire course of the ball or the rocket or whatever the problem is talking about, as long as you can see that entire bump, you're good to go. Your picture might not look exactly like mine, but that's all right. Okay, so there's a visual representation of what's going on here. If I want to ask my calculator the height of the ball after 2 seconds, I'm going to go into that calc menu. So I'm going to hit second and trace. And I would recommend with these problems, if you're stuck, if you don't know where to go to this calc menu, because just about everything you need is in there. And you can probably look at it and kind of figure out which option you need to use. Okay, I want to calculate the value. So I'm going to choose number 1 when x equals 2 for 2 seconds. And it tells me that at 2 seconds, I'm 27.9 meters off the ground. Okay, so my answer here would be 27.9 meters. That should be the exact same thing you get if you would plug 2 in for t. And then it says estimate how much time it takes the ball to fall to the ground. Well, looking at my graph again, remember time is the x-axis, so each one of these little dots down here is a second. I set it to go out to 5 seconds. If you remember from the window, my x max was 5, so I know this is 5 over here. This is somewhere between 4 and 5. I would guess maybe about 4.5 seconds. Okay, And it is okay that that's an estimate. We haven't talked yet about how to solve for that mathematically. There is a way to do it. If you said something like just under 5 seconds, that would be appropriate too. Okay, on to number 11. Consider this parabola. Now notice that that is written in vertex form. So I'm going to start by just writing what vertex form looks like over and above. Oh, let's see. Hey, sorry guys, it's been a long day. X minus h squared. Hopefully you can tell what that's supposed to say. Remember that the vertex is your h value and your k value. In that order, you have to do h and then k. So my h number is this 2 here. And I know it looks like a negative 2, but remember that became negative when I put it into the problem because the negative was already in the formula. So when I pull this number back out, I really want it to be a positive 2. And then when I pull my k value out, that looks like a plus 1, like a positive 1. But remember, it only became positive when I put it in the formula if it was negative to begin with, because when I do minus a negative, that's how that becomes a plus. So this is really a negative 1. Your vertex is really at 2, negative 1. So basically you need to take the h and the k, but when you pull them back out of the equation, you need to flip them to the opposites of what they look like in the equation. Because remember, that equation makes them the opposite. You need to flip them back when you take them back out. Okay, axis of symmetry. Easiest thing on the planet. Axis of symmetry is always just x equals the first number from the vertex. So x equals 2 would be your axis of symmetry. Okay, what direction the parabola opens? For that, I want to look at the a value. Our a value is 2. It's that number in front of the parentheses. And since that's positive, that means that my parabola opens up. If that was a negative number, my parabola would open down. Now this one, part D, we have not talked about in class yet. We will cover it tomorrow again before you take this quest. But wider or skinnier than average, that's also having to do with that a value. If a is a number that's bigger than 1, then it's going to be skinnier than average. Okay? If a is a number that's less than 1, it's going to be wider than average. So our a value is 2. 2 is bigger than 1, so this is going to be skinnier. And I will come back to that when I show it to you on my calculator, when I show you a picture of the graph. Okay? But we'll discuss this some more in class tomorrow. And then it says it actually wants you to graph the parabola. Now, I can get started right now. I know that the vertex of my parabola is supposed to be at 2, negative 1. So it's supposed to be right there. I know it's going to open up, and I know it's going to open up, and I know it's going to be skinny. But if I want some actual coordinates to put on here to make sure I'm putting this in the right spot, I'm going to use my graphing calculator. Just remember that when I use my graphing calculator, here is your original equation, because I scribbled all over that one. That to use it, I need to move this 1 to the other side. Now I could go through the process of simplifying all of that, but really as long as I have y by itself, I'm okay. So this would be 2 times x minus 2 squared. And then when I move that plus 1 to the other side, it's going to become a minus 1. And that's what I'm going to put in my calculator. So I'm going to go to y equals, I'm going to clear that screen off. I'm going to type in, just trying to make it so you can see both. Okay. Y equals 2 times parentheses x minus 2 squared minus 1. Hit graph. Now, at this point, many of us would be freaking out a little bit. That doesn't look anything like what it's supposed to look like. Well, that's because my window is still set from that last problem that we did. I need to get back to a regular graph that looks like this one. So to reset your window, you can always go to Zoom, and number 6 is standard, and it'll take you back to a nice regular window. Okay? And then again, it's still not good enough just to sketch it. I want to look at my table, which is up above graph. And I'm just going to pick a couple of these coordinates that look reasonable to fit on my graph. And it looks like these ones right in the middle would be the best place to look. So I already have 2, -1 on there. That's this middle point. That's the vertex. Then I've got 1, 1, and 3, 1. So 1, 1 would be here. 3, 1 would be here. And then I've got 4, 7, and 0, 7. 2, 3, 4, 5, 6, 7 would be here. 4, 7 would be here. And that should be plenty of points to get yourself a nice smooth curve. Oops. Okay. So that's what your parabola should look like when you graph it. So I very strongly recommend that you use the table on your calculator to get some specific coordinates to graph. If you just draw a rough sketch and your line's in the wrong spot, you're going to be in some trouble. Okay? And then I just wanted to show you one more thing that pertains to this skinnier or wider than average. I'm going to go ahead and graph. This is not something you would have to know how to do for your quest, but I just want to clarify this piece of it. If I didn't put the 2 there, if I just left it as a 1, which means that I don't put anything there at all. Okay, so you can see the only difference between those equations is this top one had the 2 there. Take a look at this. This is the one we had before, and then that second one that popped up, that was my new one. Do you see how the original one is skinnier than that one in the middle? That's considered like average. So this one here on the outside, that's an average parabola, and putting the 2 in there made it skinnier. And again, tomorrow in class we'll talk a little bit more about why that is. Okay, but that should be enough to get you through for your quest tomorrow. So, we will take some time to go over this in class tomorrow. Please feel free to ask questions or email me if you have concerns tonight. And I will be at school by 7:30 tomorrow morning, okay, if you need help with anything. Have a great night.